Hello, in this video I will be talking about my observations, the computational model I built, and comparing the two for the Lab01 in Physics 2211. I collected data by tracking the position of the object over time using Tracker. My observed position data started at nearly 0 and increased gradually as time passed. For example, at 0.033 seconds, the observed position was about 0.0106 meters, and by 1 second it had grown to about 0.302 meters. The motion was smooth and linear, suggesting that the object was moving at a constant velocity. To model this motion, I used a simple kinematic equation for constant velocity. X of t equals x sub 0 plus bt, where x sub 0 is the initial position and b is the constant velocity. From my data, the observed velocity was calculated by looking at the slope of the position versus time. Between 0 and 1 second, the object's position changed about the velocity of 0.303 meters per second. My model predicted a slightly higher velocity, specifically 0.348 meters per second. So the predicted and observed velocities did differ, but only by 0.045 meters per second, which is roughly 15%, supporting the idea that the motion was relatively constant velocity. Three main assumptions were made in my model. Constant velocity as the first one. I assumed that there was no acceleration acting on the object. 2. Negligible forces. I treated friction and air resistance as negligible so that the net force could be considered 0. Third, precise measurement. I assumed that the tracker's measurements of position and time were accurate, even though in reality, there may be small errors due to human condition. Now, what if I flip the axis C's in Tracker? If I made positive x point left instead of right? Well, the results would look like the object was moving in the opposite direction. However, the magnitude of the velocity and position would remain the same. Only the sign of the values would be flipped. This means the physics of motion does not actually change, only the perspective does. In my model, setting the net force equal to 0 gave a very good agreement with my observations, but that doesn't mean no forces were acting on it at all. In fact, there could be multiple forces like gravity, normal force, even small frictional forces that cancel each other out. So the net force being 0 means the sum of all pushes and pulls is balanced, resulting in no acceleration. The object simply continues moving forward at constant velocity due to Newton's first law of motion. To summarize, my observations showed nearly linear motion. My constant velocity model matched the data closely, and the assumptions of negligible acceleration and balanced forces were key. Flipping the axes would only change the sign of displacement, and the 0 net force condition reminds us that many forces can add up to balance each other, not that there are no forces at all. Thank you for watching.